Exercise 10.3. Without using a calculator, find the value of each of the following using MPR on your calculator to check your answer. So 8P5 is the 8 factorial, 8 minus 5 factorial, because we know that MPR is n factorial, n minus r factorial. So this one will equal to 8 factorial over 3 factorial. Okay, so then this one will become the 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. So this one cancel. So we have the 8 times 7 times 6 times 5 times 4, then 6,720. So if I have the 8P5, so this is 6,720. Then this is the 6 factorial, 6 minus 4 factorial. So 6 factorial over 2 factorial. So we have the 6 times 5 times 4 times 3 times 2 factorial over 2 factorial. Okay, so this one cancel. Then we have the 6 times 5 times 4 times 3, then it's 360. So this is equal to 360. So we have the 6P4 is 360. Yes, correct. So next, 11P8. So 11 factorial, 11 minus 8 factorial. So 11 factorial, 3 factorial. So 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 10 times 3 factorial. Okay, over the 3 factorial. So we have the 11 multiply 10 9 8 7 6 5 4. So this is the answer. Okay, and we have the 11P8, also same answer. So this is the answer, 6652800. 7P7, then it will be the 7 factorial, 7 minus 7 factorial. So it will be the 7 factorial over 0 factorial. So 7 6 5 4 3 2 1 over 1. Actually it's the 7 factorial. So it's 5040. The 7 factorial also same. So from here we know that actually if we have the NPN, it will be n factorial. Okay, next, find the number of different ways that 4 books chosen from 6 books be arranged on a shelf. So this one we have 2 methods. So we want to choose 4, then we have the 6 5 4 3. So we have the 6 5 4 3. Okay, then it is 360. We can also have the 6 big 4 permutation, 6P4. So we have the 6P4, 360. Okay, pi arrange pi, 6P4, 6 arrange 4, 6 pi 4. So next, how many 5-digit number can be formed using 1 2 3 4 5 6 7 8 9? So we have 9 here, no digit can be repeated. So 5 digit then we have the 98765. So we have the 9 times 8 times 7 times 6 times 5. So it is 15120. We also can find P5, 9P5. So we have the 9P5, then same answer. Okay. Number 4. There are 8 competitors in a long jump competition. In how many different ways can be the first, second, and third prize be awarded? So 8P3. So we have the 8P3. So this will be the 336. Or we can have the 876. Then it is 336. Number 5. Find how many different 4-digit number greater than 4,000. And 1, 2, 3, 4, 5, 6. No digit can be used more than 1. So 4-digit greater than 4,000. Then we can start with 4, 5, 6, 7. So out of 7, after we use 1, we have 6, 5, 4. So this will be the 4 times 6 times 5 times 4. So 480. Or we can say that for the first number is out of 4 we pick 1. And then the next 3 here we have out of 6 we pick 3. So we have the 4P1 multiply with the 6P3, then it's 480. Yes, 480. Number 6. Find how many even number between 5,000 and 6,000 can be formed from 2, 4, 5, 7, 8, 9. So it must start with 5. And then even number between this. So we can have the 2, 4, 8 here. Then only it is even 3. Okay, so out of 5, after we use 2, we have 3 left. 3, 2. So this is 18. Question number 7. A 4-digit number is formed using 4 of the 8 digit. 1, 2, 3, 4, 5, 6, 7, 8. No digit can be used more than once. Find how many different 4-digit number can be formed if there are no restriction. So we have 8P4 for A here. So we have the 8P4. So 1680. B. The number is odd. If it is odd, then we have the 1, 3, 5, 7. 4 number can put at the ending there. Then out of 8, we use 1, we have 7 left. 7, 6, 5. Okay, so we have the 7 times 6 times 5 times 4. So it is 840 for B. And C, the number is greater than 6,000. So greater than 6,000, we can start with 6, 7, 8, 3. Then 7, 6, 5. So we have the 7, 6, 5 times 3. So this is 630. And then the number is odd and greater than 6,000. Greater than 6,000, we can start with 6, start with 7, start with 8. And then odd, then it can end with 1, 3, 5, 7, 1, 3, 5, 7, 4, 1, 3, 5. 7 cannot because 7 used here already. Then we use 1 cut, 2 cut. So out of 8 we use 2, we have 6 left. So we have the 6 times 5 times 4, then it's 120 times 3, it is 90. So D here we have the 120 plus 90 plus 120, 330. Okay. Question number 8. Number are formed using 3, 5, 6, 8, 9. No digit can be used more than 1. Find how many different 3-digit number can be formed. So A here we have 2, 4, 5, 5p3. So we have the 5p3. Then it is 60. Okay. Number using 3 or more digit can be formed. So B, we have 3 digit, then it is 5p3. 4 digit, then it is 5p4. 5 digit, we have 5p5. So the B here will be the 5p3 plus 5p4 plus the 5p5. So we have the 5p3 plus 5p4 plus the 5p5. Then it is 300. Okay. Yes, it is 300. So question number 9. Find how many different even 4-digit number greater than 2000 can be formed using 1, 2, 3, 4, 5, 6, 7, 8 if no digit may be used more than once. So more greater than 2000. Okay, 4 digit, 1, 2, 3, 4, 4 digit. Greater than 2000 and even, so we can start with 2, 3, 4, 5, 6, 7, 8, and then we can end with even, right? 2, 4, 6, 8. So this one we have okay, minus 1. Okay, 4. So we have 8, 6, 5, 6, 5. 8 minus 2, 6 here. 3, 4. So this will be the 4 times 6 times 5 times 3, 360. So this will be 3 times 5, 6 times 5 times 4. This is 360. So 360 plus 360 equal to 720. Okay, correct. Solve MP5 equal to 720. Okay, so this is the n factorial, n minus 5 factorial equal to the 720. So 720 is actually 6 factorial. Okay, so this is 6 factorial. Then this one is actually n minus 1, n minus 2, n minus 3, n minus 4, and the n minus 5 factorial, also minus divided by n minus 5 factorial. So it is 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. So this one we cancel. So compare, we will have the n equal to 6. So we have the 6p5 is equal to 720. Yes, correct. B here we have the n factorial n minus 3 factorial equal to 7n n minus 1 n minus 1 n minus 2 n minus 3 factorial over the n minus 3 factorial is 7n n minus 1. So n cancel, n minus 1 n minus 1 cancel, and then the n minus 3 n minus 3 cancel. So we have the n minus 2 equal to 7, n equal to 9. So we check the answer. We have the 9p3 is 504, and then we have the 7 times 9 times the 9 minus 1, then is 504, so correct. Then this one we have the np5 equal to 3 np4, n factorial n minus 5 factorial 3 times n factorial n minus 4 factorial. So these two cancel. Then we have the n minus 4 factorial over n minus 5 factorial equal to 3. n minus 4 n minus 5 factorial over n minus 5 factorial equal to 3. So cancel. So we have n minus 4 equal to 3, n equal to 7.